And I will start recording since it's 2:02. So hello folks, welcome back to our last day of class. Is this anyone's last day, like for the semester? Anyone have more classes after this? Last one? All of undergrad is over today. How does that feel? Pretty good. Yes. I had a student who was saying this is her last class of graduate school earlier today. So that also, I imagine, feels pretty good. Yes, an end of an era. Would you like to see how your class is doing with respect to evaluations? You are at 19 out of 23. 2 more. Bug your friends. As mentioned in class Tuesday and as announced over email, if I get at least 21 out of 23 of you to turn in a university course evaluation by Sunday, the whole class gets a point of extra credit. And you should have received on Tuesday afternoon an invitation via Qualtrics to complete a separate survey. That is what I designed, has more specific questions, and you can also earn a point of extra credit for completing that, each of you, so regardless of how many of you do it. So going for a representative sample, dare I hope the population. That's my objective here, is to get as much representation as possible. Let's see, in terms of things that are still outstanding, grades were updated on Tuesday morning. The only thing left would be revisions to homework 5, if you choose to do so, and homework 6, which is a data analysis using M+Stata or R to do a path model. Both of those things need to be turned in by the end of finals week. To help you with the completion of any remaining tasks, I will be having office hours my usual times, Mondays and Wednesday next week from 12 to 1:30. In addition, the time I would normally be spent teaching, I'm spending in office hours Tuesday, Thursday, 12:30 to 3:30. So plenty of time if you want any last minute help on things, but please plan to have everything turned in by the end of finals week, no exceptions. So we've got some catch-up stuff to do regarding mediation with multivariate normal outcomes in multiple groups, and then looking at a couple examples with generalized. I know that some of you need to go to a talk that starts at 3 o'clock. I think it's on the other side of this floor, though, so not very far away. If you do need to leave early, no worries. I won't take it personally. But given that folks may be leaving early, let me just begin by wanting to say to each of you a very sincere thank you for making it through the semester with me, for all of your efforts. I know you all worked really hard. I hope you all feel very proud of what you've learned and what you've accomplished. I certainly do. And if there's any way that I can help you in the future, let me know, because you've earned the right to bother me by having made it through this class. So I am happy to have, graduated another set of generalized modeling students. Before then, we have a little bit left to do. So 6A is what we were talking about on Tuesday. Here's the path model that goes with this. These are real data from a real publication. Link is provided right here. We're looking at the extent to which the connection between mindfulness and warmth towards feminists is mediated by 4 different flavors of sexism. Internal motivation to respond without it, external motivation to respond without it, hostile sexism or benevolent sexism. And I am not a social psychologist, and I don't know what these words mean, but you can read about it in the paper. From my perspective, as labeled here, we have 1 X, 4 M's, and 1 Y. So last time we went through the process of building the first path model, in which we had all of the connections that are given by the diagram, as well as residual covariances among the mediators. And we got this output. This is page 2 of example 6A, which tells me what, as a review question here? What does it mean to have a test statistic of 0 with 0 degrees of freedom for my path model? I'll give you a 3 alternative forced choice. How's this? Good news, bad news, or consequence of my model? Consequence. Also, what is accepted good news? So the 0 value means that I have no difference at all between the height of my model relative to the best possible model, which is the saturated model. The fact that I have zeros for degrees of freedom means my model is what vocabulary word? It is always consequence. You're right, Chris. Starts with a J? Yeah, just identified. I spent everything. It has to fit. Now, do I know if I have anything worth reporting in a paper yet? But don't know that yet. That's effect size. So what fit means is that I have adequately recreated the patterns of relationship in my data with my model. Doesn't mean I have any patterns worth talking about. So to answer that question, we got to dive into the results. And last time we had seen that we have two direct paths from X to the mediators, internal motivation to avoid sexism and hostile sexism in particular. And we ended up with, let's see, where are the M's? Here we go. We also have direct paths from those M's to the outcome. So we have the A part, we have the B part. That means it makes sense to ask about indirect effects, the extent to which the relationship between X and Y is different after controlling for these mediators than before. There are multiple ways to do that. I did it in R by making it do the math for me. So this colon equals is a way to get linear combinations or nonlinear combinations, basically anything that you can dream of. These are labels that are attributed to each of the paths. So for instance, here's X to M1, X to M1. What that's going to do is figure out what that estimate would have been and use it in the equation to generate an outcome. Not only will it generate an outcome, it will give me a standard error for it and a hypothesis test. So in your homework, I asked for several indirect effects. This is one way to go about getting them, is to code them yourself. If you are using, let's see what software, M+, there are two ways to get indirect effects. One is to do the math. So a similar concept and set of syntaxes to what Lavon does, not a coincidence. Lavon was made to copy M+, as near as I can tell. We have labels, so for instance, X to Y, X to M1, M1 to Y, and so forth. I then use those labels to create multiplicative terms, that is the indirect effect. So model constraint is the command to do this. New means it wants you to label each of the computed quantities ahead of time and then tell it how to compute it. The easier way to do it with much less typing, which is applicable in this model, is model indirect. So if I type this, it will give me all of the indirect effects from mindfulness to warmth with much less typing. And you can use this in your homework as well. So then those results down here indicate that, let's see, this one and that one. So that means that there are two significant indirect effects, meaning the relationship between X and Y is different after controlling for the first mediator and the third mediator. Typically, we don't interpret these coefficients because they are both in units of X and units of M. What people often tend to care about is just whether or not they're significant. And this is one case in which the p-value is not likely to change if I did anything more rigorous with respect to bootstrapping relative to just letting the Sobel test do its thing like we normally would do. Okay. So any questions about any of that so far based on what we did Tuesday? Feeling good with that? So what if I told you this is only half the story? Her research question was, to what extent does this model work differently for undergraduate men and undergraduate women? That's the question. Because her moderator, as it is known, so whenever you're asking if effects differ as a function of some other thing, that's a moderator. Because it is a categorical variable, and the way she collected it was a binary variable, there is a very straightforward way to do this. You don't even have to put gender in the model. You can do what is known as a multiple group model. So let me show you what that would look like as an example. This is what is known as moderated mediation, meaning the extent of mediation is moderated by a separate variable. All of the packages can do this, including ProcCalus in SAS, which is in the download folder if you want to learn how to do it that way. Stata has some really nice features to do multiple group structural equation modeling with not very much code, but it prints a whole lot of information. Can you guess what the new part is with respect to allowing this path model to differ by group? Any guesses? It's one more line that wasn't there before. Group, yeah, that. So what you're saying is, hey, you know this whole giant path model I just asked for? Can you make that for men and women separate at the same time? Cool, thanks. So the key here is that the model is being separated. It's being estimated within each group specifically, but simultaneously. The simultaneously part is important because then it allows us to directly compare each of the slopes and each of the indirect effects and anything else that we want to across groups. So doing separate analyses by gender would not allow us to answer the question as to whether there are gender differences in the extent of indirect or direct effects. G invariant. So this is a term that you will hear in the world of structural equation modeling when it comes to testing whether things work the same across groups. And variance testing is also known as measurement equivalence. In the context of item response models for categorical outcomes, it is known as differential item functioning, or DIF. So these are all the same concepts. We're answering the question, does this model work the same way across groups? And G invariant none is a shorthand that says let everything differ across groups. Don't put any constraints, don't make anything the same, just let everything be different. Here is a bunch of code that answers the question whether or not there are differences between men and women in the direct effects of interest and in the indirect effects of interest. So we have NLCOM used before as this is the path for, it looks like, the 0 group and the 1 group. So I think, I'm trying to remember who's the reference in this case. I should have looked at that before. We'll find out. Doesn't really matter. One's the 0 and one's the 1. So the 0b and the 1 refer to specific values of this indicator variable. Oh, it's MW, that means men are the 0. That's my coding scheme. And so this is the indirect effect for men. This would be the indirect effect for women. And then you see the minus sign out here? Literally the difference. So how different are the indirect effects across gender is being tested via this statement right here. So it's not forcing them to be the same. Instead, we're letting them be different and then testing the differences. So I did that for the first, second, third mediators. And then I also asked for comparisons of the direct effects directly within here. So we have this extra piece right here provides a whole bunch of extra output as to whether the direct effects differ by gender, so I don't have to write all those out. So again, the point of doing separate models by gender simultaneously is to get comparisons across them done for you efficiently. Here is what it would look like in R. Lavon, unfortunately, requires a lot more typing. I'm sure there's a way to shortcut this, but I don't know what it is. The way to do it in R is to label each parameter with 2 different labels. So down in the call to Lavon, it has an option for group, and you tell it what variable is your indicator of who's who. And so then it understands that the first label is relevant for the first group, the second label is relevant for the second group, and so on. So I have an M in front and a W in front for my own sanity to keep track of these things. But the fact that I have 2 labels means I'm not forcing them to be the same. I'm letting everything differ by group. I computed indirect effects for both groups, and then I asked for total effects for both groups, and then differences in direct effects across groups and differences in indirect effects across groups via all of these labels. So the labels that are used down here refer to the labels that are used up here. Okay. So questions on the setup or the point? Zoomers are quiet. Still with me? There's the thumbs. It's like a response time task. Oh, she called on me. Shit, I'm here. Guess what? Model fit is still perfect. I still spent all my degrees of freedom. Now I have twice as many because I have the model being estimated separately for two groups, but I still spent them all. So then it tells you, this is our output for Levon. Group 0, what is the model for the men? And it also includes your labels, which is helpful, at least the truncated versions. So it gives you what would happen in one group. So it looks like we have significant direct effects there for mediator 1, but not mediator 3 in this case. We have significant effects from the mediators to the outcome for 1 and 3. That was the same as before. Residual covariances for the 4 mediators. R-squares, the extent to which each of these things is being predicted. Then we get the results for women, and lo and behold, some of the patterns are not the same. So in women, there is no direct effect from mindfulness to warmth. It looks like we have the third one there is still there, and 1 and 3 are still there. Then the real question is to what extent there are differences across groups, as indicated by all the parameters that I carefully defined. So these are the indirect effects for men and women by mediator. So it looks like we have a significant indirect effect through M1 for the men, not for the women. For 3, now it's neither are significant. Total indirect effects are the next batch. Then we get differences in direct effects. So this one, for instance, we need to have the total effects available to know what the sign means, because negative either means it's less positive or more negative. So x to m4, for instance, if we go back up and look for that, x to m4 is that one. So it is a positive effect in women that is marginally non-significant, but x to m4 in this one is a significant negative effect. So the way I would describe that is that there's a significant negative effect in men, there's not in women, and those effects are significantly different. So you can go through the same logic that we've seen all semester. Functionally speaking, what I've done is estimate interaction terms. It's the same idea. So if you have a multiple group model and you have separate intercepts for group, that would correspond to saying I have a main effective group. If I have separate slopes between x, m, and y per group, that's like saying I have a group by slope interaction. So it's the same idea, just done in a different way, which is useful when you have categorical moderators like this. And then we get to the differences in the indirect total effects, and so forth. Here's what it looks like in M+. Changes, grouping equals. So you have to tell it what variable controls that and what the labels are that you want to see on your output. One thing that I skipped over too quickly last time that I wanted to draw attention to. Do you see how bootstrap is commented out right here? And so is C-interval bootstrap. That's because in M+, you can either have robust estimation or bootstrapping, but not both at the same time. So I think what I ended up doing is using robust estimation for all of the primary model results and then going back and rerunning it with the bootstrap turned on instead for the standard errors, because I did not want Reviewer 3 to yell at me about that. If I can avoid a conflict, I will. So then in terms of the specification, we have model the same as before, but then we have this new piece down here, model women. So that means that model implicitly is for the reference group, which is the 0 group coded men in this case. So that's why I have the lowercase m in front of all of my terms like this. In terms of a pro tip for coding things, M plus is not case sensitive, but you can use lowercase versus uppercase to your advantage. So the way that I wrote, for instance, this whole chunk of code was to copy the model for men and then tell it, hey, everywhere you see a lowercase m, stick a W in there instead. Lowercase m specifically. That way the rest of my labels with capital M would not get messed up. So if you're careful in your coding, you can hack it so that it is a little bit more efficient. But the key idea is that each of these parameters, slopes or intercepts or variances, is being labeled differently for men and women, and that's why it's going to be kept separate. Then last but not least, the same model constraint with respect to gender-specific indirect effects and differences across direct effects and indirect effects as well. And then the much shorter way to do it that's available in this model. So fit is still perfect, don't need to worry about that. The results are grouped according to the multiple group specification, so group men, and it typed men because that's what I told it to when I told it up here that 0 meant men. So using helpful labels will make it easier for you to understand your own results in the future. And there we go. So we have an indirect effect by group for men. There's my total effect. I'm highlighting the ones that are significant, the difference between men and women in the direct effect, and the difference in indirect effects between men and women as well. So this way of doing it allows you to be able to ask for differences across any parameter, so it's efficient. It's technically not the best way. A likelihood ratio test is considered like the bestest way possible, but in order to do that, you would have to constrain effects, rerun the model, release them, constrain other ones, rerun the model, and it's a much more labor-intensive process. But this is what it would look like if you wanted to do that. So we have, in this case, I'm holding constant warmth as predicted by mindfulness. There's no labels to that, whereas I'm allowing different effects for men versus women via the 0 and the 1. In R, I did the same thing by constraining the label to be only 1 word rather than 2. And in M+, I would do the same thing by using the same label for both the men model and the women model. That makes it a constraint, that you're saying it has to be the same, and then you can see how much worse the fit gets via that constraint. So then we get actual results for our tested model fit, because what you're actually testing is the difference in that one parameter that you constrained. Ta-da! "14 pages, done and dusted. Not even my best effort. I'm not sure what my record is, but I think it's somewhere in the 40s. Yeah, I once had a handout that grew to 70 pages, and I was like, this is a lot. This is even for me, so I had to split it up. But it's a lot of code and a lot of stuff. So this is an example using everything that's multivariate normal. But what is this class called again? Generalized, right? So what happens if you want to have, let me get a picture up here. What if warmth towards feminists needs a link function? Could I do that? Sure I can. The question is what kind and what software? So I have several choices for your reference with respect to what is available in terms of generalized models. So on, for instance, just for your reference here, we've got slide 32 describes what's possible within M+. There's an alternative type of estimation that works for binary or ordinal outcomes within M+ that you might be familiar with. On slide 38, I have all the choices for Stata, considerably more. But Stata's GSEM is not as good at handling missing data. It only uses pairwise equations. The biggest difference is that if you don't have a single covariance matrix that summarizes all of your data, you don't have an answer key. You don't have a comparison of what the best model is to come back to. So model fit is evaluated differently, cough, cough, homework question, when you have binary outcomes and you're using maximum likelihood, or any of these other kinds of outcomes. we have 2 examples to show you, and at this rate, we might even get done by 3. Who knows? Not this one yet. Example B. 6B. This is a paper that I wrote all about one correlation. I'm not kidding you. I found one correlation, I thought it was interested, and I wrote a whole paper about it. Now, it looks like a real paper. This is published in Psychology and Aging, which is a reasonably good journal in the world of aging. The only key that it might not be that exciting of a paper is right here. It's 4 pages long, because this paper is what's known as a brief report. And it was the easiest review experience of my life. Because when you write a tiny little paper, there's not much to complain about, and people will read it and review it quickly. So no finding is too small to be put out into the literature. Most journals have a brief report type of section that you can submit little tiny papers to. But the story with these data is, for my dissertation, I did a data collection study of 152 people that was looking at the extent to which measures of cognition and attention, including one that I particularly cared about because I made it, would predict risk of driving impairment in older adults, and it was measured via performance in a driving simulator. In the original study, none of my measures predicted actual driving performance because I was able to get permission to access their driving records and their accident histories, and nothing in my entire data set was related to that. But after a few years passed and I wasn't as sick of my dissertation as I was at the time, I decided to revisit this. And so we paid a research assistant to call up all my subjects on the phone and say, hey, remember that thing you did at the hospital where you did drive in the car, the pretend car 5 years ago? Have you hit your mailbox or gotten a wreck or gotten a speeding ticket? Has anything happened with respect to your driving? And so we followed up people. And we were able to collect data from 114 of the original participants, and 14 of them had been in an accident that we qualitatively coded with a series of distinctions and landed on at least partially at fault. And 14 of them had also had a speeding ticket. So we decided to examine the extent to which the measures collected 5 years previous would relate to these outcomes. And here's the correlation matrix among all of the variables. And here's my path diagram, which I'm very, very proud of. Because this is very busy, but I feel like it's somehow still understandable. So the original variables, gender, age, I have a latent factor that was turned into a factor score of visual impairment, processing speed, 2 measures of attention, and the thing I cared about. All of those things predicted their performance in the driving simulator. And then all of those things also predicted a new covariate I collected at the follow-up as to what extent they're still driving or have they voluntarily limited their driving. Nothing predicted that. Those were considered my mediators so that I could have missing data on simulator impairment, and then predicted the 2 outcomes of whether they had an accident that was at least partially their fault or a speeding ticket. And it turned out, as indicated by the title of my paper, simulator driving performance predicts accident reports 5 years later. That's my correlation. People who did worse in my simulator turned out to be more likely to have an accident 5 years later, which I would argue gives the simulator, even though it was really low end and crappy, some degree of ecological validity. So accident category is a binary variable. Speeding ticket is a binary variable. So what do I need to do for them? What changes do I need to make relative to a typical path model if I'm predicting 2 binary outcomes? What kind of link function might I need? Something in the logit family. Logit, probit, log-log, complementary log-log would be other choices. And what kind of residual distribution? Is it going to be normally distributed? Can't be. What is it instead? Bernoulli. What if these were ordinal variables? What kind of link function do I need then? Still in the logit family with an important adjective in the front of it for ordinal. Starts with a C. Cumulative, yeah. Cumulative logit, multinomial distribution. What if these were nominal? That's counts. Nominal is the example Vladimir is going to do. That one is still multinomial, but with a baseline category logit, where it's like you dummy code your outcome categories, that one. What if these are counts? Yeah, Poisson or stretchy Poisson. And if you're looking for stretchy Poisson in the help manual, what is that thing called? Negative binomial. Yeah, so all the things that you learned, no problem. Now there's a few complications in terms of what indirect effects would mean. So if I wanted to compute the indirect effect, say, from age to simulator impairment and to accidents, age predicting simulator impairment, because this is a continuous variable, is just a standard regression slope. But what metric is it in from simulator impairment to accidents? It's in logits. So that's where it gets a little bit weird to try to interpret it, because the A path is in identity link and this is in logits. There's nothing that stops you from doing it though, and you can compute indirect effects the same way, and they mean the same thing in terms of the extent to which the relationship between x and y differs as a function, or after including the mediator. By the way, I figured out that the C minus C prime thing, that's why people do standardized slopes, because you get so closer to that answer. So, but the way we did it is fine. So I had this model without the blue thing here, and I got 2 questions from my reviewers. Now, let me foreshadow this with the output from the model. These are the only fit statistics that I got. That's it. The height of the data, AIC and BIC, and that's it. There's no other fit statistics that are possible, because you can't easily summarize the pattern of relationship for binary or ordinal outcomes in a covariance matrix. It doesn't work. So I didn't report any fit. And the reviewers were like, hey, you didn't report fit of your POF model. And I told them incorrectly that I don't need to, because it's just identified. I was incorrect because I was missing this relationship right here. The reason I was missing it is because I tried to do what I knew how to do in 2008 or so, when this was happening, and try to say accidents with speeding tickets. And M+ is like, no! You don't have a normal distribution, you don't have residual variance, you don't have residual covariance. So I was like, okay, you're right, I guess I can't have that, and I went about my day. But I fixed it, because now I know how. This thing out here is labeled random intercept. This is a latent variable, that's why it's in a circle. This is the indirect way of putting correlated residuals into a model, which is the only choice you have for generalized outcomes when you're in full information maximum likelihood. What this is essentially doing is allowing these 2 things to have an extra relationship, the extent to which is characterized as its estimated variance. Both of these blue lines, these slopes, would be fixed to 1, and the variance would be estimated, and it stands in as basically the equivalent of a covariance. So this is how you would have to do it to allow outcomes that are generalized to be related to each other in full information maximum likelihood. So the reviewer had a point on that. But then they also said, well, how do you know that the arrows should go this way? That was an actual comment that I received in a review. How do you know that the arrows are going the right way? Like, maybe X doesn't predict Y. Maybe Y predicts X. Have you ever thought of that? Now, normally, I'd say you have a point. But in this case, I absolutely know they're going the right way. Do you know why? These 2 boxes happened 5 years later. And last I checked, the past cannot cause the future. So I felt very good about defending my choice of the arrow direction in the past, predicting the future. Now, with respect to these boxes over here, predicting this one, they might have a point, because these are collected at the same time. But do you know why I did it that way? Missing data. I wanted simulator impairment to be in the model for people who had missing data, because it's not missing at random. The people who we were able to get follow-up data for who are missing simulator impairment were because they got motion sick in the simulator and they weren't able to complete the task. That is not at random. So I wanted those people still in as part of the analysis. So in terms of the code, I did this in M+ because it's the only package that will do full information, and I have a Stata example also that doesn't match because of the way it handles the missing data. Categorical equals is how you tell it that you want binary or ordinal outcomes. I have link equals logit to tell it what link function I want, and it understands based on categorical what kind of distribution it should be. The only other things that are different, rather than having intercepts, M+ gives you thresholds, which is intercept times -1. It's going to give you the logit of the probability of the lower category instead of the higher category. Otherwise, I was able to put all the direct paths in that I was interested in. Here's my new random intercept factor that allows me to have covariance between my two binary outcomes. I loaded them onto it. And then here's an example of how I would do an indirect effect via model constraint, because in these sorts of models, you can't do model indirect with the shorthand code. So M+ is using all 114 people to compute this model. This is all the fit that I get. So the only thing I know is that this fits relatively better or worse than other models, but I don't know if it fits absolutely. So inside the download folder for this example, I don't have the original data since it's real data, but I do have what was reported in the paper versus how the results changed after I added in the covariance via the random intercept. So we have which results were still there, which ones became significant, the one correlation that was the reason for the publication, and then I didn't do indirect effects in the publication, but I did demonstrate what they would look like here. M+ also gives you odds ratios, which are effect sizes instead, because we don't have R² for binary outcomes in an unambiguous way. In Stata, I'm using GSIM to do the same analysis. And the one time that Stata will let you have capital letters is in naming latent variables. It insists that they start with a capital letter. I shit you not. That's it. They reserve capital letters for imaginary things. Otherwise, you can tell by the end of the option here, comma logit, what kind of model I'm asking for in predicting accidents and speeding tickets. Here's an example of my indirect effect. And I'm asking for odds ratios as well as effect sizes. So the way that it handles missing data is indicated by this first piece of output here. It tells you for each variable that's being predicted how many cases it used. So it does what is known as pairwise completion. It only uses, like for each equation, what observed outcomes are there. So it's not working with all 114 cases at the same time. So the results will differ relative to what M+ did. But here are the slopes predicting speed and the slopes predicting accuracy, as well as predicting the mediators of limiting driving and simulator driving impairment. Ta-da! So there's a results section in the original paper that you can see that describes these findings, if you care. All right, so the process of generalized summarizing, you got to figure out what link function, what distribution, make sure your software can do it, and then everything else pretty much works the same way, except for model fit. You don't get absolute model fit instead. Questions or comments? Okay, Vladimir, you want to show them nominal real quick?
Oh, yeah.
Okay, told you we're rolling through this. We're getting it done.
Yeah, great. Do you want me to present?
I do want you to present.
Okay.
Did you know that?
No, but that's okay. I like to talk about these things.
Yeah, you do. Wing it.
Okay,
There you go.
thank you, Lisa. So, well, this is the second part of the long project that I'm working on related to the admission system in Chile to selective higher education. So, for this specific part of this project, you will see that this file explains a little bit of the context again. It is the same thing that we covered last time for the logistic binary regression model. However, now with, with the path analysis, I'm trying to tackle one of the limitations that we found in our last study related to this picture that I showed you at the end of the study. So here you can see that the probabilities of admission were similar if we consider the quantile family income. However, based on gender or sex and type of school, the things were different. However, in Chile, there is a discussion about the effect of family income in your probabilities of being admitted to selective higher education. So I said, okay, maybe now we cannot see the effect of family income, but maybe if we try to disentangle this effect via path analysis, we can see what the differences are. And of course, the other thing that we tried to tackle here was the fact that we didn't include people who didn't apply, because we saw that including that people, we were overestimating the probability of not being admitted, but they didn't apply. So that was a mistake. Now, with those two things in mind, with Lisa, we try to fit this model. This is a path analysis. Here you have the academic factors. These two are the college admission tests, and these two are the scores related to the GPA in high school. This variable, however, now has 3 levels, because using this new variable, we have 3 categories. First of all, people who didn't apply. 2, people who apply and were selected. And 3, people who apply but they were not selected. Now, we chose that order because in M+, by default, the highest category of your dependent variable is used as the reference for the submodels. So if you know how to change that, please email me. And these are the set of regressions that we are fitting. We can see that we are using now first generation instead of parents' education, because I think this is like a summary of that information. And again, family quantile income. Here we have the direct effect between the socioeconomic factors and the academic factors. These are the A's, and these are the B's, which are the direct regressions between the academic factors and our dependent variable. And we will see the indirect effects later, which are the multiplication of A and B's. And of course, we have the direct effects here between these variables and the outcome. And here you can see between first generation and the outcome. Long story short, this is the most important part, because we are estimating 2 submodels. The first submodel is at ADM pound 1. This is the comparison between those students who apply, who didn't apply compared to those who apply and were admitted. Zero. Oh, and yes, yeah, you're right. And were not admitted, and this other set of predictors are predicting the probability or the comparison in the probability of apply and being admitted versus apply and not being admitted. Yeah.
So the first submodel is the new part. It's like, what is the probability that people take themselves out of the running to even get in?
Yeah.
After they see their test scores? Like, who is likely to eject at that point and not even be possibly getting into school?
Exactly. Yeah. So, yes, and well, we have a brief description in this document that you can read, and at the end, I will go directly to the end of this, because regarding the research question, we found that the effect of the family economic quantile was significant even after controlling for the academic factors that the admission system assume are the main factors and the main reason why people are selected. So that was interesting. Yeah, and this is like a draft version, so maybe you will see a improved version later. Oh yes, sorry. Yes, now. Yeah, how to do this, because this was a challenge. And finally we decided to use the nominal model based on our outcome. So here you can see our dependent variable with the labels. We decided to use the maximum likelihood robust estimator, and here you can see the paths. So for the first submodel, you have the 4 mediators there, and the other set of socioeconomic factors. The same for the second submodel, and here you have the labels that we use these labels to compute the indirect effects later here, which are part of the model constraint in M+. So I think that's all, right? Yes. So thank you. Great.
So yes, this is another case in which estimating an empty model to start with, so you know what the hell it's doing. Step one. There's no other way we would have figured out like what the reference group is and what pound 1 means and pound 2 means, right? This is somewhat obtuse. So figuring out what the submodels are doing in the first place will help you figure out what should go in. So then it's an empirical question, or your choice, as to whether the same predictors predict each submodel or not. So in our case, we wanted to examine the predictors of everything, but that's a choice, which is why you can list them separately within M+ here.
Lisa,
Yeah,
can I add something?
sure.
Because I forgot something important there.
Okay, where am I going?
In the last page,
Okay,
you will see an explanation of the indirect effects. However, that's incorrect. That's not true. I forgot to change that. 'Cause
okay,
I thought that the indirect effects were interpreted as the effect of your predictor on the outcome after controlling for the mediator. However, that's what the direct path is doing. So the indirect effects, you will see in the other file that they are interpreted as were significant or not. That's
okay.
all.
So I should get rid of this?
Yes, please.
Okay, done.
Yeah, but can you explain that maybe, because that's important, I think, the difference between what the interpretation of the indirect effect.
Yeah, so what an indirect effect means is that the relationship between X and Y differs if you include that mediator or if you don't. That's what it means. So it means the bivariate relationship is different than the unique relationship. But you'd have to dive into the results to figure out anything more specific than that. Different than is really what the significance of an indirect effect refers to. And in your case, because you have 8 million people in this example, it's not surprising that everything is significant.
Yes.
So you probably want to do effect sizes or something to sort of follow up with this, although not everything is on the same scale. So for instance, going back to the path model, which is a very nice diagram, by the way. How did you do this? What software did you use?
In Stata, you
Oh,
have
in Stata.
SEM Builder.
Okay, so Stata made this for you,
I think so, yeah.
and then you made it prettier?
Yes.
Excellent. I especially like this little divided box thingy. I think that's very effective. Like each of these is a yes, no, first gen, income, and so forth. The middle ones are per 100 points. And so the odds ratios are necessarily going to be bigger for these because it's like a more of the variable. So it's hard to compare odds ratios for different kinds of variables, even though they're supposed to be effect sizes, but you can compare them if the variable is measured in the same way. So that's one thing to keep in mind as well. All right, did you want to say anything else about that?
That's all. Yeah.
No? Okay, see, I told you I could do it. All right, any other questions about anything before we call it a semester? Not just a day or a week. I'll let you out early so you can all go to the talk. That's happening on the other side of the hall here. No? All right, then thanks for hanging in there, folks. Let me know if you need anything. Otherwise, I hope you all have great summers, and I'll hope to see you again. That's it. Peace out for the last time. Bye, Zoomers. Bye, Roomers.